let's look at a tangent line example. Line L is tangent to the graph of y equals e to the x at the point k comma e to the k. So just putting k into the function. What is the positive value of k for which the y-intercept of L is 1/2? All right. I'd probably start with a sketch. Y-intercept of L is 1/2. Y equals e to the x. So I've got this line L. Its y-intercept is 1/2. So it's got to look something like this. I guess that's a point. K comma e to the k is a point. That looks good. So line L is a tangent line. So I would always start with y equals mx minus x plus y. And then start kind of filling in the things I know. What's my slope? Y prime equals e to the x. So my slope at k would also be e to the k. So we can kind of start putting all that stuff in. Y equals slope x minus my point. So now I need another point on this. So this is the tangent line equation, but I also know that it goes through the point 0 comma 1/2. So I can put that into my function for my y value and my x value, and I'll be all set. I can solve that just with one variable then. I'd probably clean it up. That's not a parenthesis right there, is it? 0 equals e to the k times negative k, so negative k e to the k plus e to the k minus 1/2. I'm going to go ahead and put that in my graphic calculator. And I think that graph, let's go ahead and draw it right up here with this guy, looks something like this. And we're looking for the positive value, so I'm looking for this value when that's equal to 0. So I'm just going to go second calculate intersection. And I think I get 0.768. There it is. That was a good one. Point slope form, derivative of a e to the x. We got that move. All right, we've got a particle problem here. A particle moves along a line so that its velocity is given by v of t equals negative t cubed plus 2t squared plus 2 to the negative t when t is greater than or equal to 0. For what values of t is the speed of the particle increasing? All right, so we got to look at, we've got a velocity, and we want to know when is speed increasing. Well, that would be, if we just go ahead and graph that. So if we get the graph, I think from 0 to infinity, it looks something like that. So my suggestion probably would be, if we're talking about a velocity graph and we're looking for speed, is to actually graph the absolute value of the velocity. When we graph the absolute value of the velocity, it's just going to give me a little bounce there. It's going to keep going. So now I'm looking at a graph of speed. And where is it increasing? Well, it looks like it's increasing from here to here, and then it's decreasing, and then it looks like it's increasing from there to there. So really, we kind of just need to look at where is it decreasing. I would go second calculate that maximum right there. And I think that tells me 1.256, which has represented quite a few of these things. And then I would go second calculate 0. And I think that tells me 2.057. And then I would decide, it looks like it's definitely increasing from there to there. So from 0 to, oh, I guess I'd have to look there. And I think if we look a little closer, it actually decreases just a little bit until there. So I might second calculate a minimum as well. I'd calculate the minimum right there, and that is 0.177. This maximum was 1.256. This 0 was 2.057. So we are increasing from here to here and from here to here. Looks good. All right, we've got a table of values representing x, f of x, g of x, and f prime of x. The table above gives the values of the differentiable functions, the derivative of f, at selected values of f. If g of x equals f inverse of x, what is the value of g prime of 4? So we've got an inverse. So we want to maybe rederive, which is probably a good idea. To do that, we go f of g of x equals x. And then we find our derivative, f prime of g of x times the chain rule of g of x equals 1. So g prime of x, the inverse, is 1 over f prime of g of x. And there we go. So now I want g prime of 4, 1 over f prime of g of 4. G of 4 is actually negative 2. F prime of negative 2 is 4. So my answer is 1/4. All right, and finally, if f of x equals x cubed minus x squared plus x minus 1, then f prime of 2 is, we've got a nice little, do you know how to use the power rule? F prime of x is 3x squared minus 2x plus 1. Put a 2 in, and 12 minus 4 plus 1 should give me 9. All right.